So let's talk. I missed the last podcast I was supposed to give. I did do the unboxing instead, but just to get caught up. So we were talking about reliability, maintenance, energy, and reliability. And so far we focused primarily on electrical signature analysis. Now, there are a lot of other technologies. There's also a lot of other systems that will have a tremendous effect on your reliability and maintenance program and energy and environmental reporting. Now, we're going to start into a little bit of that, and we will occasionally either provide updates or additional information on a study that we've launched. I just finally got the equipment. I'm waiting for a couple of final components that go along with the unboxing of the new empath that has the vibration capability. So we already tested that yesterday at Joliet Equipment. We did a comparison between what we were seeing in kilowatts and then also what we were seeing in vibration. So we did find that the relationship is valid and it's there. So the study, which we are going to put the first release out in the January-February CBM Connect conference or CBM conference, and then we'll be covering that again in a couple other conferences later in the year. We'll provide that detail. We'll get into the relationship of energy and emissions associated with vibration detection, with the direct relationship using the kilowatt readings that we get with the empath unit. So there'll be quite a bit coming up. We already know what it is theoretically, and we already know what the limits are. Sorry about that. I am 10 hours into a 14-hour drive. This is not unusual. But in any case, this week we're going to be, I'm heading to IEEE standards meetings on electrical machinery testing and insulation testing. And then we're going to be at a Bitcoin mining site looking at the impact of ground and neutral harmonics on their energy consumption. Now, there's a sizable plant, several megawatts for this particular one, a small one actually. Most of them are 5, 10, one's 400 megawatts, so they can be quite sizable. But we're going to take a look at that, and next week, because we're in New York, just so happens I will be during Memorial Day. I'm sorry, Veterans Day, not Memorial Day. Hunting for sasquatch. So basically, where can we find the hidden? Where will we find the hidden opportunities? So this will be quite interesting, especially next week, and we'll combine those adventures. So in the meantime, the next step we're going to cover is a little bit on some of the work we were doing in 97 through 99, and then again later with DOE as part of the Save Energy Now program, the stuff that we have already published related to the work that was done during that project while I was at General Motors. So there are quite a few opportunities people don't realize, and it is frankly disturbing that we focus on everything except a measurable area, and as a matter of fact, not just a measurable area, but an area seen as highly important to our companies, such as just plain the energy bill. I mean, everybody wants to reduce energy consumption, and the number one way to do that is through the proper maintenance and reliability testing and adjustment and improvements as part of that program for for our maintenance programs. So everything from cleaning tubes and chillers. I mean, we noted that at National Institutes of Health as a for instance. That was huge. That was direct tax dollars. And other opportunities along those lines. Everything from precision maintenance versus standard maintenance. Even if I am, even if I'm meeting minimum specs, I mean, the opportunities are still huge. That even went when we were taking a look at things like life of bearings, right? So if I meet the minimum vibration standard, so in balancing, the minimum balancing standard for an electric machine of 1800 RPM versus, that would be a 2.5 versus a balancing rating of 1.0. The difference is having 96% of the bearing life at a 1.0 versus 25% of the potential bearing life at a 2.5. I mean, that's astronomically different. And at the same time, the losses associated with the direct vibration and unbalance are measurable between the two. And we'll get into that as we return to part of that study. So there's quite a bit, like I said, information coming up. So a quick recap, things that we have covered. Opportunities related to power harmonics. Back in the 1990s, we thought that 2% was what we would see, and then it also included ground and neutral harmonics. What we're seeing right now is those values, we have not done a site yet and where we've implemented some of those corrections that has not fallen below 10% reduction in energy. And we've seen as high as a third reduction in energy through the use of harmonic mitigation in both power and ground and neutral. So the opportunities are astronomical. And then when we get into things like loose connections and power factor correction and things like that, that all adds up to a total of another 2%. Now, 2% doesn't sound big, right? Until you start taking a look at the costs over the course of a year. So say I'm at say I'm a 1 megawatt plant, right? What's 2% of a megawatt? I mean, that's not a small number. And then I take that and I'll take a look at that times how many ever operating hours for the year, and that number will pay for any of the program necessary to make those corrections. Now let's talk about things like steam, right? So when we get into things like, and this is what we're going to cover next, not today and not next week, but the week after, we're going to cover some steam system stuff. When we start talking about steam systems, did you know that in the study that was performed in the 1990s, they determined that 10% of your steam traps fail per year? So if you're not maintaining those steam traps over the course of the year, that adds up relatively quickly. And the result are significant losses. That means that I will have a significant opportunity for energy savings, fuel savings from my steam program. That doesn't include things like putting lagging on steam pipes in order to prevent loss of steam, right? If you have exposed areas, you've got two issues. One is your steam starts producing condensate in the line, which can cause all kinds of issues to the components that it's being used on, but also damage to the piping itself, and the need to mitigate the additional heat that you're putting out into your spaces. So that can have an effect on areas that are air conditioned. It can cause heat stress for employees, can cause heat stress for equipment, valves, valves and electronic equipment. So a long list of things in addition to the energy savings, right? So when we start taking a look at when we don't do things from a precision standpoint or an improvement standpoint, or even, and of course a reliability standpoint, there's always an energy cost to that. So once we begin to take that link, the other hunt for Sasquatch is that communication with the C-suite. Let's talk about what we're up to this week. So after our meeting, we're going up to have a chat with the folks at one of these locations. But I'm not meeting with their maintenance guy, and I'm not meeting with, their energy. I'm meeting with their CEO. So we're going to meet with their CEO, and then we'll also have with us the CEO of Onyx Energy Solutions. And we're going to be looking at a problem that they're having with ground and neutral systems. So I'll cover a little bit of that. We'll determine what they want to share and if they want to share it. But we're going to discuss some of the issues we run into in that environment in general, because we've been seeing a lot of these organizations now, whether that's, like I said, whether it's Bitcoin mining or data centers. And why are those important? Well, right now they're more than 5% of the total energy consumption for the entire planet in electricity. A minor amount, right? When we consider that all of wastewater and water, including all the pumping systems, comes out to about 2% of the total energy consumption worldwide, and steel mills are somewhere between 2 to 2.5%. We're talking about astronomical numbers. And that don't even get me started on things like Internet of Things, right? I just finished reviewing a study this last weekend in which they're talking about an astronomical increase in energy consumption due to data centers for IoT devices for information that will generally not be utilized for anything. Yep. So we're talking about IoT for the sake of IoT, resulting in more than 25 billion devices worldwide, and a total memory requirement it was a number I'd never even heard of. Just the massive amount. And when you consider 7 kilowatt hours per gigabyte, and by the way, we're talking about not a little number. So everybody's claiming that they've attached their data centers to clean energy. There's not that much clean energy in the world right now to cover all those data centers. Pardon me for the shaking, by the way. I'm testing a mount, it's a window mount, and it's vibrating a little bit. I'll take a look at this later and determine if I'm actually going to post it. But getting back to the other, we're talking about an astronomical amount, which gets me into a whole other subject. And that subject has to do with the fact that, let's take one case. I was involved in an organization that was taking in a lot of information. A lot of information on all kinds of things, including, I forget, I can't talk about how many data points on the machines, on the electric machines. Well, as it turns out, I was asked by the data scientists for that site when we were discussing it, said, what of this information can we use to determine the condition of a machine? And I said, actually, all of it we could use. But in reality, when I do go back and I say we're finding this kind of issue with these machines, the question I get is not, of all the information and all the, and the pressures and the, this, that, and the other thing, what are the final decisions they actually asked me for? Well, vibration, ESA, and temperature. That's it. So they'll ask me for one of those three things during the operation of the machine, and not any of the other stuff. And I go back on that with a short story, and that was again related to the IoT devices and what their values are. Sometimes, you have to be aware that IoT devices, they fail too. They have a reliability capability as well. And counter to what is discussed, the more complex a system, this is a law of reliability, by the way, the more complex a system, the greater the chance of failure, the reduction in overall reliability, right? We know this. This is a fact. Nolan and Heap published it. I mean, it's the more complex you make the system, the more chance of failure. And I got that stories next. So one day we're sitting there in a meeting. I was at a site, and I was sitting in their morning meeting, and a gentleman comes in and he says, we've got to shut down this one critical motor now. We've got a high temperature alert on the bearing. And so because I was there, somebody said, hey, what do you think? And I said, I don't know, what's the temperature of the bearing? And he said 50,000 degrees. I'll let that sink in. And I said, well, what you basically said is we've been incinerated because that's hotter than the surface of the sun at 25,000 degrees. So as it turns out, the IoT device had been damaged and was shorted and was putting out its max scale, which happened to be ridiculously high. However, it was calculated in the system. So it had been damaged, and therefore they were getting a high reading. So we sent somebody down to take a look at it. That's what they found. Now I get into, let's say, the vehicle I'm in. I've got, this is the newest purchase for MotorDoc. This is a Silverado Trail Boss with a 3.0 turbo diesel, basically a baby diesel with on steroids. Which part of the reason I got it was, well, I like the power of a vehicle. I actually use these to go off-road, to get to job sites, wind turbines, and some other types of sites we go to. And they stopped making the 8-cylinder. So it's like, okay, I can't get my usual 5.3, which is perfect for highway. I get relatively good mileage in that. I think I was getting on average 24 miles per gallon in the old one on highway and about 19 city. Just, that's the way I drive and maintain it. So I said, why not try the baby diesel? It's been out for a few years. Most of the problems have been resolved with it. So I went ahead and made the purchase. It gets me, depending on the quality of the diesel, and I didn't realize this, when I get high quality diesel from certain locations, I will get as high as 36 miles per gallon on the highway. If I get the lower quality, like I did at this last stop, I'm at 25 miles per gallon on the highway. It is a significant difference. So I'm starting to sort out where I go. But even at that, I got a 600 mile range. So 600 miles plus range in this vehicle. Now, diesel puts out a little bit more in emissions than gas does. But when I weigh it out, I end up reducing my vehicle carbon footprint by about 15%. I think it came out about 16 or 17% on average. So not too bad. And part of that was this really cool radio system. And, as I mentioned, I spent a lot of time in a vehicle. So in this case, I got their latest edition of the radio system, which turns out to be Android, which we won't talk about that. But the first thing that happened on first road trip was I would stop and I'd start up again, and it would decide that I didn't need the sound in the sound system anymore. That included directions, radio, everything. So it would just stop. And took a little while, but we upgraded it finally. The dealership took 3 hours to do the update, but after the update, I haven't had any more trouble. The other thing with that is diesels are rather complex. I'm probably spending more time on maintaining this vehicle than I had in the other vehicle. And the first thing that occurred, because we have an additional system to make it even more complex called DEF. That's diesel exhaust fluid. Diesel exhaust fluid is a type of urea, and yes, that's what it sounds like, that is injected into the exhaust system to interact with the output or the emissions from the burned diesel fuel. This diesel fuel is basically not as refined as gasoline. So it's a thicker oil, right? So if you have an oil boiler or something like that, you're using some form of diesel, right? So vehicles use type 2. So we have type 2 diesel in here, and then as a result, we inject this into that, and it reduces certain nastiness. And in the meantime, when I take the next comparison is CO2, right? So a gallon of regular gasoline comes out to be about 19 pounds of CO2 per gallon burned in an average vehicle. In a diesel, it comes out to be about 23 pounds per gallon of diesel. So we do certain things in order to reduce the reduction and go for the higher mileage. And I guess some people turned against diesel because they looked at the per gallon, but not the efficiency of a diesel engine. So I've got a much more efficient, I get almost a third more vehicle mileage on average than I did on my old vehicle. So say the old one, the average came out to be about 20 miles per gallon. And in this one, the average comes out to be about 29 to 30 miles per gallon. So that's 10 more miles per hour, 1/3, or the other one was dropped by a third. So when I start taking a look at the opportunities for efficiency are better, but the complexity of this vehicle results in more potential defects and more maintenance needs than in a standard vehicle. Now, with all the other electronics in modern vehicles, they have to be designed with an extreme level of reliability in order to improve the total reliability for the vehicle, right? So when I take a look at the radio, what's the importance of the radio? Well, it's more important than you think, because the radio is actually also used to do updates to the entire system. I mean, I'm holding on to the steering wheel right now, but the steering wheel does not necessarily have a mechanical linkage to the wheels anymore. The brake system does not necessarily have a linkage to the braking system, and the gas pedal doesn't have a direct link to the ignition or to the fuel system. Instead, it's all done electronically. So that adds a level of complexity. And when I was involved in the development of certain electric vehicles, looking at that reliability became extremely important, because we needed to see that every component adds up, so that if I have a low level of reliability in one component, the whole system has a low level of reliability. Now let's get back to the energy aspect, right? So more complexity, the need for higher reliability, the more complex system, the higher chance that one component can fail, or one component that have a low level of reliability can affect everything. And if I don't maintain that, then I have a direct effect. Well, also, if I don't maintain it, like the fuel filters in a diesel, I'm going to have to replace it. I mean, I bet 16,000 miles right now. So at 20,000 miles, or between 20 and 25,000 miles, based on what I'm seeing right now on the screen, I'm going to have to replace the fuel filter. What if I don't? Well, then the machine has to work harder in order to do what I need it to do, right? And that's going to generate more need for fuel. So maintaining the vehicle, and that's what I did with my gasoline vehicle as well, allows me to maintain the level of efficiency and range that I expect. Same thing happens in our factories. So if I go in and I don't maintain my compressed air system, well, what's the average efficiency of a compressed air system? Somebody suggested 30%. Well, sorry, that might be the compressor. That's not the system. The average system is about 11 to 14% efficient by the time it comes out the nozzle. So it basically takes 9 horsepower to create 1 horsepower of compressed air. So what do I do? Well, things I need to do are maintain it, ensure that I actually need compressed air for the system, used point systems, and there's all kinds of other things. We're going to get into that later on as well. All of this, again, goes back to the calculators and the resources I talked about in the last several episodes related to the Department of Energy challenge programs and related software systems. So anyways, I'm approaching heavier traffic, so we're going to end this at this point. I will check and make sure that this is not too jiggly. If it is not, then this will go up. Next weekend, I will post our adventures. At some point, we're going to start interviewing people, but that'll be a few episodes down the road. If I get a chance to talk to the owner of Onyx or the owner of the data center that we will be working at, I will include that. But we will go in search of Sasquatch. That's kind of my Veterans Day plan, coming back through the Adirondacks. So with that, be safe, be energy efficient, and be reliable. We'll talk later.